So in this video, we're given that the velocity of a person moving in a straight line is v of t equals 1/2 t squared minus 3t plus 7/2 feet per second. So time is in seconds, velocity is in feet per second. And what we're going to do is we're going to use the midpoint rule with 5 intervals to see if we can figure out how far this person has traveled. Now, what we need to do is we're first going to do this on the interval, we probably should state that, interval 1 to 5. So here's 1 to 5. Alright, and we can see that for part of it, the velocity is positive, for part of it's negative, and part of it's positive. So this person's walking forward, backwards, and forwards. So we're actually going to calculate a couple different things. We're going to calculate the total displacement, or the total change in position, and the total distance. So a couple pretty interesting things. Now, we're going to do this with 5 intervals, which means we got to take 5 minus 1, or 4, and split that into 5. So 4/5 is our delta t. So that's the very first thing we're going to do is 4/5, or if we want to do it in as a decimal, 0.8 is our delta t. So let's mark those points off. So right there is 1.8. About right here is 2.6. Right here is 3.4. Right here, notice each time I'm going up by 0.8 is 4.2, and then we got our last interval of 0.8. Now, because we're going to do a midpoint rule, we need the midpoints of each of those intervals. So let's get those while we're doing this. So the midpoint here is 1.4. The midpoint here is 2.2. The midpoint here is actually already given to us, it's 3. The midpoint here is 3.8, and the midpoint here is 4.6. So now we can draw in our rectangles based on our midpoint rule. So we'll have a rectangle here. We'll have a rectangle underneath. We'll have a rectangle made from the 3 here. We'll have another rectangle underneath. And then this one will be made above. Okay, so we're going to use this to get our estimate of the midpoint rule and the distance traveled. So, the midpoint rule, we need all the heights of these rectangles, and we're going to multiply them by our delta t. So let's do the midpoint rule. That'll give us our change in position. So 4/5. And now to do this, we're just going to plug in our values of our midpoints into v. So v of 1.4 plus v of 2.2 plus v of 2.6 plus, these are the wrong, 1.4, 2.2, v of 3, that's the wrong value, v of 3.8 plus v of 4.6. We can do a quick check now. 1, 2, 3, 4, 5. So we have our 5 intervals. And if you calculate this, it comes out to be negative 1.44 feet. So what that means is this person's total change in position is they moved 1.44 feet backwards. They went forwards, backwards, and forwards. Now, we're going to use our work to get the total distance traveled. So total distance, we're going to do something similar, but all those negative areas we need to make positive. So we actually are going to get the values of each of these. Now the width is still 4/5. What we need are these function values, and it turns out v of 1.4 is 0.28, which is fine. So 0.28. v of 2.2 is negative 0.68, but we need that to be positive, so I'm going to add the 0.68. So what I'm doing is I'm making the 3 that would normally give us negatives, I'm making them positive. v of 3, if you put 3 into our function, you get negative 1, but we want it to be positive, so I'm going to add 1. And Same thing with the other. This is also again a negative 0.68, so we're going to make it a positive 0.68, and then this was already positive, so it stays, so 0.28. So these three that were negative in the total position calculation, we forced them to be positive because we want the total distance traveled. And if you calculate that, you get 2.336 feet is the total distance he traveled if we count forwards and backwards. So you can see the difference between the two. So the last thing is, if we wanted to see what this converged to, you could start to do the midpoint rule with more intervals. So just using some computer technology, Wolfram Alpha in this case, I calculated M of 10 is negative 1.36, and I calculated M of 20 to be negative 1.34. And what we could see is as we take the number of rectangles to go to infinity, it looks like this actual area, or the actual area between the curve and what the midpoint rule would eventually give us is negative 1 1/3. And what that would be is our change in position between 1 and 5 seconds given this velocity function.